Hi, everyone. Thank you for joining us. Really happy to have you here for the very first in our monthly learning series. So today is going to be brought to you by 11 Radius co-founder Asheen Pensay. And the title of today's learning series is Assessing Product and Supply Chain Hotspots with LCA. And so as mentioned, what we're going to do is a little deep dive into LCA, and then we have a guest presenter, Alexandra from Doconomy, who's going to be joining us to do a demo of their platform. So I am currently recording this, and it will be available on our Slack channel later in the day. If you have questions, there are a few options. You can either put them in the Q&A below, and we will try to get to as many of them as possible. If your question is specific to either Asheen or Alexandra, maybe just mention that, so that we will have a few minutes between the two presentations in order to do a little bit of Q&A and then more questions at the end. You can also raise your hand if you want to ask your question live, and I will jump into the participant list and bring you up to the stage to be able to ask your question live. And then if you have just comments, feel free to put them in the chat, but try to keep the Q&A or the questions in the Q&A section, just so we can keep them segregated, you know, like separating peas from mashed potatoes. All right, so I'm going to hand over the reins to Asheen and let him get started, and we'll take it from there.
Thanks, Tara. Hello, everyone. And let me share my screen so we can get ready to do this deep dive into lifecycle assessment, or LCA. This is an interesting topic that we've been slinging around a lot in the world of circular fashion. For those of you who have seen our framework for circularity, our 11-point framework, you'll notice that LCA isn't a bubble on the framework. And the reason is that we view LCA as a tool to support many of the facets of circularity, just like other tools like carbon footprinting, like data and the way that data plays through the supply chain and chain of custody. So it's an important tool, and it's an important way to start assessing some of the realities and trade-offs in the facets of circularity. And so what we're going to do today is sort of dive in a little bit into a couple of aspects of LCA. Certainly, you know, in 30 minutes or 90 minutes can't get everyone up to speed in order to kind of go out and go forth and conquer the world of LCA, but I can give you a good overview. So we'll start with understanding life cycle thinking as sort of a precursor to LCA, which is the sort of calculation tool, if you will, to make life cycle thinking real. We'll go over a little bit of the Lca process. It's an ISO certified process, so you'll get a sense of what that looks like. And then perhaps most importantly, how and where to use some of those LCA results once it comes out of it. And then, as mentioned, we are going to be having a demonstration where you'll actually get to see, hopefully, sort of some of what doing an LCA looks like, and be able to ask some questions about more the tactical approach to the nitty-gritty of doing one. Let's talk first about life cycle thinking. So hopefully you've all kind of thought through the process of when a brand brings a product to market. There's a lot of steps involved, and certainly we can measure the environmental and social impacts of each of those steps. So we tend to start on the top of this diagram. This is a typical sort of life cycle thinking or sustainable design thinking diagram that you may have seen. We start with raw material extraction. So that could be for natural fibers, it's back to the farm, it's growing the cotton or whatever it is, and the agricultural inputs into that for a synthetic fabric, or ultimately fabric, or a synthetic component of a shoe, for example, like a neoprene or something. This would be the crude oil extraction and all of the inputs that go into that, and all of the effects that those have on whatever populations are in the place where that extraction is happening. So that's raw material. We go into processing. This is, you know, carding, spinning, et cetera, for you know, natural fibers. It's the fractioning of crude oil into the, you know, to pull off those pellets, those resin that you need to then start to make fibers and fabrics in terms of synthetics. We go into the part manufacturing or just manufacturing. So this is making the fabric, this is making the components of the shoe, if it's synthetics, and then of course assembling them in an assembly plant. So this is perhaps using some energy, some glues, some other impacts or other materials that and energy that have impacts. Then it's the use phase. So that in this diagram, this is sort of a general life cycle thinking diagram across many different industries. So you see the mobile phone there, and that's a reminder that some products in their use phase do draw energy and create impacts. That's not typically true for garments and for shoes, although we do need to think about things like when you wash garments, you'll have some effluent, you'll have some sort of microplastics going out in the wash water. You'll also have a decent amount of energy going into the heating of the water to wash. So we'll talk a little bit more about that. And then end of life is usually some portion is recycled, some portion goes to landfill, and some portion is incinerated. And so each of those has a different set of impacts. And you have that last arrow that hopefully closes the loop more and more into bringing it back to raw materials. So this is the idea of life cycle thinking. How does this play out when it comes to bringing a brand to this idea of life cycle thinking and for them to bring a product to market and to talk about that product's life cycle? So it turns out that there's some quick and dirty ways that we can bring life cycle thinking into the design process. And then there's a spectrum of more and more robust ways. And we'll talk about life cycle assessment as sort of the most robust and generally most expensive in time and cost way to bring life cycle thinking into the design process. But I want to walk you through that progression as we get to LCA. So the first sort of general category is simply design intuition. And I've given on the right some examples from the fashion space of what I see as sort of design intuition or the progression of life cycle impacts or sort of life cycle thinking. And this is not to judge at all. It's not a judgment to say that a brand just uses design intuition and doesn't use full LCA, because it's a journey, and it's important to step on that journey and to start down that path. And in fact, if all you have is sort of how we think about the life cycle and we don't have the data to do a full LCA, then this is a great place to start. And it's important that these brands are doing it. And so design intuition is really, it's asking some good questions. And so, Prana has, and I should also say, these are all public facing statements and screenshots that I got from web pages. It sometimes is the case that companies are doing more than they show on their webpage. So one can assume that this is sort of the minimum that they're doing, if you will. And so Prana asks some good questions about what materials were used in this piece of clothing. Where do they come from? Who made it? How long will it last? These are all questions that can eventually be answered by, mostly answered by a life cycle assessment, but it's important to start thinking about these questions as we build the design process and build our products. Then you might go to a qualitative way of looking at it, like a company scorecard. This is from Threads for Thought. So there's, as you can see on the bottom, there's sort of a sliding color scale of, on the far right is sort of the lightest green is like, okay, we do the industry standard. And then I don't know why they're progressing from right to left here, but then we're a leading example, we're setting the example, and then we're doing something really innovative that leads the industry forward. And so they've sort of given themselves a scorecard for the dye process, the water usage. They feel we're really innovating and doing something really unique. In some other areas like traceability, we're sort of just meeting the standard. And so you'll notice that this doesn't map exactly to the life cycle of, from materials and flowing through as the product flows through the supply chain. But it's a good sense of how do we assess the different parts of our supply and value chains and kind of start to rate ourselves on these different impacts, if not life cycle stages, at least the impacts that result from them. And so you'll see some of these sort of self-scoring, qualitative types of things as you start to become smart on life cycle thinking and use that as a lens to look at some of the brand's materials. The next is what we would call conceptual life cycle thinking. So this is applying a bit more rigor, but still sort of in a qualitative sense. There may be some data behind it. The data might be anecdotal, or it might be kind of spotty, in terms of like, we think it's, half our footprint is in the materials, or, something like that. But it's still a way to start working through the different parts of the life cycle in a more systematic way. So this is from Kariyama, which looks at, as you can see across the top tabs there, materials. So you're starting to see that map back to that wheel that we showed. Materials, factories, which would be part manufacturing and assembly in our diagram. Operations, which is partly, one thing I didn't mention is just transportation sort of between each of those steps and those little arrows in the circle. And so operations would cover, the sort of assembly or manufacturing part of it, and then some of the logistics, et cetera. So, if you, as I have here, focus on the material tab, they do go through some of the materials they use and say, what is the impact of this material as we trace it back to the source. And so this is sort of understanding the story behind all of the product life cycle, which is a really good first part. I mean, if you don't know what's in your products, if you don't know, if you're only looking at your tier 1 supplier and saying, okay, I'm kind of trusting them to tell me what's in it. If you're not looking beyond to the tier 2, 3, 4, and sort of back to further up in the supply chain, this is then a really good place to start, which is just starting to ask those questions of your supply chain and learn what's in it, how is it made, who makes it, where is it made, back to those questions that Prana asked at the top, but starting to answer them, starting to come up with that understanding and start to tell that story to external folks. And so that's what we'd call conceptual life cycle. And then we get into sort of a full LCA, a full life cycle assessment. There are a lot of companies that do this, but don't talk about it publicly. They don't necessarily show, okay, here's a product carbon footprint or whatnot. And so, here I have, you'll get another example of what it looks like to do a footprint when Alexandra will, shows you the 2030 calculator. And so I wanted to give you just another example here. Sorry, Alexandra, for showing a different one, but this is from the HIG product module from the Sustainable Apparel Coalition and HIG company. And so this is what you're seeing here is what they call their MSI, or Material Sustainability Index, which is a set of data, essentially a set of materials, and then it's applied to different ways of sort of working through the LCA process. And so this is sort of what a typical LCA looks like. It's a bunch of charts, it's a bunch of data and tables that rate. And as you can see here, we're looking at global warming potential, eutrophication potential, water scarcity, and et cetera. These are different environmental impacts that an LCA can measure on. We've, in a sense, started to coalesce on measuring on carbon footprint as one of the metrics, but there are many other environmental and increasingly social metrics on which you can measure the outputs. We'll get a little bit more to that. So I will pause and ask Tara if there are any questions at this point, because I'm going to dive into a little bit more of the LCA process.
No, you're all good. You can move forward.
Great. Either you are all completely following along or at least totally puzzled at this point. So LCA is a process that was defined some time ago, 1990, and CTEC put up this definition, which I think is valuable. So it's an objective process. Mostly, it's a little science and a little art. So I'm going to put an asterisk in my mind behind or next to objective, but it's occasionally a little subjective. But it tries to be an objective process to evaluate environmental burdens. Notice that simply environmental at that time. It started to get into the social LCA space a little bit. Associated with a product, process, or activity. That's important because there's different levels on which you can do an LCA. It doesn't really make sense to do it at a company level, but product, process, activity, behavior, that kind of thing. By identifying energy and materials used and wastes released. So material in, material out, energy consumed is pretty straightforward, and then the impacts of those. And to evaluate and implement opportunities to affect those impacts and those improvements. That's a little, I would say that last bit is a little aspirational. It's a measurement tool, and it can highlight some areas in which you can improve, but it won't tell you how to improve per se. Here's one thing that I want you to take away from when we get to LCA results and what they look like. And the key is LCAs answer specific questions. It's not as sensible to say, let me do an LCA of the product and see what impacts it has. You can do that, but an LCA will answer the questions that you ask it. So let's get a little bit more specific. What activities in the product's life cycle contribute most to its overall impact? This is what we call a hotspot analysis. What are environmental consequences of changing a material or process? I'll give you an example of that later. How do I choose as a decision-making tool between or among different environmentally preferable choices? Whether it's a type of adhesive that I'm going to use, whether it's a trade-off, like should I recycle this locally or should I ship it to a great recycling facility in Italy that I found that can recycle more of my product but incurs some shipping costs? What is the environmental cost associated with that, with those two options? So these are sort of the specific questions that this process will answer. So let's talk about the process. This process is an ISO certified process, ISO 14040 or 14044. It has 4 steps. So first is the goal and scope, figuring out what questions we're asking and what are some of the characteristics behind those questions. Then doing an inventory. What's in the product and what's in its life cycle? What's in its supply chain and value chain? What are the impacts of all that stuff that we measured in its supply chain and value chain? And finally, what does it mean? How do we interpret the results that we found? So diving in a little bit, and I'm hoping Alexandra sort of highlights a bit of how this traces through the 2030 calculator as well, because all reputable LCA tools will have either very explicitly these 4 steps or implicitly throughout the process of how you do it. So goal and scope. What's the context of this? Are we doing what's called a cradle to gate or a cradle to grave? You may hear these terms, so I wanted to explain to you what they mean. It simply means how much of the life cycle are we looking at? Cradle to grave, as you might guess, is from inception to death. So it's the entire life cycle. Cradle to gate is typically, it can mean any gate, but it's typically if you're a brand and you're making something, once it goes out the door, either direct to consumer or to a retailer, that's the gate. So basically you're saying, what is the impact of all the stuff that I can either control or influence within my 4 walls and upstream? Downstream, with less ability to influence what my customer does with the product in use and at the end of life. And so a lot of LCAs are what's called cradle to gate. Although I would say from my perspective, the world is starting to shift to cradle to grave types of analyses. But those are of course harder because they're fuzzier. You're basing them on assumptions of what your customers will do. But then there's questions that are more how you calculate. So what's the functional unit? Is it a pair of jeans? Is it a yard of fabric? Is it a shoe? Which sort of shoe? If you make a whole bunch of shoes, is it a typical shoe? Is it one for sneaker, one for boot, etc.? So this is sort of what's the reference unit that you're measuring. What are the impact categories that you're measuring? Is it just carbon? Is it carbon and toxicity, which by the way, LCA does pretty poorly? Is it water, which there's data is scarce. So there's a lot of different things that you could measure. If you're stuck with that and you're in an analysis paralysis, start with carbon. I think that's a really good proxy for a lot of other impacts. Where are the boundaries? Where do we draw the lines? Do we go back to the crude oil extraction? Do we go back to the drilling equipment and the impact of the metal in the drilling equipment that's used to extract the crude oil to make my synthetics? I mean, you could spin down the rabbit hole for a while. So that's why in this part of the process, you draw your boundaries and say, this is where we stop. And then you figure out where the data comes from. It could be primary data, which is I call up the actual factory that makes my stuff and say, how much energy does it take to make 1,000 pieces? And I'll divide it by 1,000 and figure out literally how many kilowatt hours are consumed to make 1 pair of boots. Or it could be I'm processing leather, and on average, Leather takes, so many kilowatt hours per kilogram. It emits, so many chemicals of certain types per kilogram. That's called secondary data. And there are databases that you can leverage to pull that data in. Or if you use a tool, that tool might be backed by some of those databases. And you can also use a mix of primary and secondary. You can say, I'm going to use secondary data for the trim and some of the things that don't impact it as much. But in my core, I use a lot of leather, I'm going to use my primary data on that. Or I use a lot of cotton, I'm going to use my cotton data, et cetera, if you can get it. And you can also improve your LCA over time by including more and more primary data. Some of these sort of LCA considerations go a little deep in allocation of burden. This is if you have like multiple products, how do you allocate the impacts among those products or byproducts? You can do different types of LCAs. Single factor would be like doing carbon footprint, whereas multi-factor or combined would be doing a bunch of things and combining them into one sort of unit of environmental badness, if you will, often called millipoints. I don't know why they're called millipoints. A point is arbitrary, so maybe if we divide an arbitrary unit by 1,000, it sounds more scientific. I don't know. I've never been able to figure that out, but there's ways of considering multiple environmental impacts all in one. So that's the goal and scope. And the idea is, for some software packages, a lot of these questions are already answered. This is how we do it. It's important to know those assumptions and understand them so we can put things into context. Other times you can answer the questions yourself. And it's important to do this step and complete this step up front, because what is the strong human instinct is to go and find your results and then come back and cherry pick some of the answers to these questions to make your results look a little bit better for you. Simple human behavior, human instinct, and to avoid it, settle these before you proceed forward. So an LCI, or life cycle inventory, is simply a flow chart. Give you a moment to look at my favorite flow chart. But a flow chart is simply what's in my product, how does it flow, how does it get to the end product, what's the supply chain look like, how do I collect that data? And this isn't necessarily impact data at this point. This is simply how many kilograms of what go in, how many kilograms of what waste product come out, and how many kilowatt hours or joules or whatever of energy go in, whether that's electrical energy, whether that's heat energy, et cetera, whether that's mechanical energy, like, or, stitching, with a machine, et cetera. And then you measure and then you allocate the results to your products. So an LCI is a fairly straightforward process, but can be the most time consuming part of the process, because what you're doing is really going to your supply chain and starting to look for answers and look for data, and convince them as to why you're asking them for the data, which is sometimes an interesting conversation. So the impact assessment, I won't spend too long on, because if you're using a tool to do this as opposed to doing it yourself, which I highly recommend, because doing it yourself is really in-depth and quite an art and a science. If you're using a tool, a lot of times the tool will do this for you. Once you build your bill of materials in the tool, it will do the impact assessment. It will classify the different inputs and output materials into different categories. As you saw in the screenshot of the HIG, there were global warming potential, there was eutrophication potential, et cetera. It's classifying outputs into which of those impacts they cause. And then it'll characterize how much of that impact is it causing. Is it 1 kilogram of carbon dioxide? Is it 10? Is it 1,000? And as I've implied, there's reference units to each of those. Kilogram of carbon dioxide for global warming potential, or a kilogram of phosphate equivalent for eutrophication potential, or a kilogram of sulfur dioxide equivalent for acidification potential, et cetera. And then sometimes they're normalized, they're weighted together in order to get this sort of overall environmental score. And so finally, how is the data interpreted? Does it answer the question that you asked? And what variables is it really sensitive to? And then what do I do about it? So again, I'll pause now and ask if there's any questions about the overall process, and then I'll give a few examples and then hand off to Alexandra and her colleague.
We don't have any questions in the Q&A at this time, and I think that's a testament to you being such a good teacher, Isheen.
I hope so.
Yes. And I'm sure there are a lot of questions, but it's also a lot to absorb at this point. If anyone does have questions for Oisin, you can raise your hand and jump in and ask them. And if not, we can wait until the end after Alexandra has done the presentation.
Absolutely. And I'm happy to also share this deck with anyone that's attending. That just send me an email, oisin@11radius.com. So I'm just going to end with how do you use some of these LCA results? So this is an LCA that I did for an office products company that asked the question, we process our products, in this case it was 3-ring binders, using a PVC shell. We've got something like $1 billion of capital equipment to process PVC. Before we start turning over that much equipment to polypropylene, which we think is better for the environment, let's ask the question, are we doing better for the environment? And the answer is, as most consultants will give you, and I was an LCA consultant at the time, the answer is it depends. So if you're looking at toxicity, at water tox, then absolutely. And the way to read this is the yellow is the contribution in a kilogram of each. It's a contribution of yellow is from PVC, blue is from polypropylene. So if you're looking at toxicity, polypropylene is way better than PVC. In this case, in these two categories, orders of magnitude better. If you're just looking at global warming or carbon footprint, they're about a push. So if that's your only goal that you're going to focus on, stay with PVC and invest in carbon reduction technologies elsewhere. So again, it's going to answer with a question that you ask it because the answers are nuanced. What about looking at different alternatives? This is a great LCA from Qantas that they published where they're looking at the whole life cycle. So this is the different elements of, in this case, coffee, I believe, cultivation, treatment, delivery, etc. But then they're looking at a number of different packaging alternatives. And what you can see here is what are the impacts of the packaging alternatives relative to each other? And also what's the impact relative to the rest of the life cycle? Am I really good, doing well by focusing on this part of the life cycle? So evaluating a couple of different options. I mentioned hotspot analysis. So this is an LCA related to photovoltaics or solar panels servicing. And as you can see here, I mean, the first thing you notice is there's a lot of light blue in adding up to 100% of the impacts on each of these different environmental categories. And that light blue is trips of technicians to sites by truck. So what this says is, rather than giving commuting benefits or changing the office equipment or getting more recycling in our office for our waste, we should buy a hybrid or an electric fleet for our technicians because that's going to reduce the impacts the most. And so is this something that you would publish to your customers? Probably not, but you would do this analysis and target your hotspots and then tell the story to your customers. We did a study and showed that the impact is here. That's what we're reducing. So how would you show an LCA to your customers? This is the canonical Levi's 501 jeans LCA done by Tom Gloria many years ago and published by Levi's. And what they found was, okay, here's, as I mentioned, climate change, water consumption, eutrophication, et cetera. These are typical LCA metrics. And they normalized it, meaning they said, okay, rather than saying, here's the number, we're going to say it's 69 miles driven in a car, it's 250 hours of TV. So they normalized things that were more human digestible. And they also said, here's how we can change behavior. So, more than a third of the impact of jeans is in the use phases, in that consumer use. It's in the heat that goes into heating the water to wash your jeans. And in fact, here we have a bunch in the fabric, but really the highest spike in consumer care. And this is what they said, hey, think about this. How would you change that? Rather than us working, we are going to be working on reducing the impacts of the fabrics, et cetera, but also you should wash your jeans less. And these are the results. If you wash your jeans for a certain, as you see here, lifetime climate change impact variance by washing frequency. So if you wash it, every time you wear it, it's 28 kilograms of carbon for a pair of jeans. If you wash it every 10 times, it's a tenth of that, right? And so this was Levi's saying, it's back to your cradle to grave, saying it's not just the part that we control, it's also the part that you can influence as to the carbon footprint of your pair of jeans. And yes, as Faith says, you can also put them in the freezer. That was another recommendation that they had. You can put them in the freezer to disinfect the jeans. You can also hang them outside without washing them to get that nice, fresh outdoor smell in them, as I do. So these are some of the ways that that LCA results can be used. I've got some links there to some more information. If you get a chance, I put this on the very top. Read the PDF that Levi Strauss released for their 501 Jeans LCA. It's not that long. It's formatted really for public consumption, and it's really informative. It will tell you a lot about how they did the LCA process and how they used it to then communicate the results to their customers. So there's a few other links there that you can look through. And in fact, I haven't updated this particular slide since the last time I talked about LCA. So Alexandra, I will make sure to add a link to the 2030 calculator before I distribute this. And with that, that's what I have for you. I would love to turn it over to Alexandra. Alexandra, can I let you introduce yourself and potentially your colleague, and then start with your discussion?
Definitely. Thank you so much. Can you hear me okay?
Yeah, absolutely.
Great. So very happy to be here. My name is, as said before, Alexandra Carnig, and I work at Economy, which is an impact startup that have several services to help consumers understand their carbon footprint that they've gained through their consumption, mainly. And one of those ways that we're doing that is that we're helping brands to measure their product carbon footprint in a little bit more, I would say, easy and scalable way than the other tools that were on the list there. So I'm happy that we will be on that list moving forward as well. So I am here today with my colleague, Sean, who's for some reason is named Alexandra as well in this call. But the two of us are working with the 2030 calculator. I'm on the commercial side and Sean is on the product side. So he knows every detail of how the service works, but especially as well the methodology that we have behind the service, which is really the key. I don't know if you want to mention a few words, Sean, about yourself. Maybe not. So I will start with sharing my screen then and begin with showing you a movie that explains a little bit about our take on what actually why we are in this space and what we're trying to do that kind of separates us from the other actors that are in this space. So I hope that you now can see my screen.
We can, Alexandra.
Perfect. But please interrupt me if the sound is not working or anything like that. I will also distribute this afterwards. Here we go.
We can't hear the sound, so you may need to narrate it a little bit.
Sorry, could not hear it?
We can't hear the sound.
Okay, I don't know why that is not working. It's been like this for me and Zoom as well. So we will skip the movie. I will distribute it afterwards instead. It's a good movie that explains, as I said, our take on this, which is that we did not aim to create a tool that is very, very specific to your supply chain, but rather something that works for all types of different companies and all types of different products, so that we can start getting a measurement out there that is actually comparable across product categories and across brands, basically. So that has been our focus from the start, to create something that works not only for your specific industry, but for others as well. On top of that, we also wanted to lower the thresholds for smaller businesses who may not have the resources, both financial or knowledge-wise, to actually use these quite complex tools that really demands of you to go into every detail of your supply chain and know your all of your materials, and every step along the way. So we are really trying to help companies that do not have those resources from the start to gain that knowledge that they need to start minimizing their carbon footprint. So by that, our goal is to, you can still see my screen now, right?
Yes, we can.
Great. Our goal is to enable you guys to, by simply using our tool and input a few things around your product, start understanding what carbon footprint that product actually has. So going back to the different points that were mentioned before around both the scope and the data points and all of that. So what we are measuring with the 2030 calculator is a cradle to gate footprint. And the reason for us focusing on a cradle to gate footprint is that we want brands to measure what they have under their control, since the steps that happen after the product ends up at the consumer's hands is really unknown. So the only thing we can do is guess how many times they can wash their pair of jeans, or if they actually end up just lying in the closet, nobody ever knows, right? So we wanted to put the power around this in the hands of the brand. So by calculating what is under control of the manufacturer, we can start making those shifts around what actually can minimize the carbon footprint for the production of that product. And then on top of that, we can start educating our consumers how they are supposed to use the product to minimize their carbon footprint thereafter. So that's the approach that we have been having so far. And I cannot see the chat now, just so you know. So if there are any questions, feel free to raise a hand or interrupt me.
We will let you know.
Great. So what we did when we tackled this problem was that we looked at different product production processes, basically, and we tried to identify the hotspots that were in each of these production processes. And when we started to lay out that map, we found that several steps along the way were actually overlapping and were actually the same throughout different production of different types of products. And all of these hotspots are really where the tool, the 2030 calculator, is focused around. So what we did is that we took all of this parts of the calculation that does not affect the end result as much, and those we automized and used average data points as far as possible to make the calculation much more easy to actually finish. And then the parts that have a large effect on the end results, the hotspots, those we made as flexible as possible. So if you have a lot of data on those specific parts, for example, how you process your materials and all the specific locations and the specific energy use, etc., then you can input that. But if you don't have that, you can also use the tool to get your carbon footprint, but of course on a not as accurate level as if you were if you actually had that data. So that's the flexibility of the tool, and how it can be used in many different ways depending on what type of user you are and where you are on your sustainability journey. And the methodology that we use behind the calculator is aligned with the ISO standards of 14067. And it, as we said, it covers all the phases that are under operational control of the manufacturer. And the key here is really that whichever product that was calculated with the 2030 calculator is then comparable to another product that has undergone the same type of calculation.
And Alexandra, 14067, that's a carbon footprinting standard, right? Product carbon footprinting.
Exactly, that's correct.
Thanks.
Maybe Sean, you can add a little more detail on how we worked with that.
Hi, yeah, I can do that. Sorry, it took some time for me to log in. I was having some problems. I kept getting kicked out. I don't know what happened there. Yeah, the 14067 is specifically for products and focuses strictly on global warming potential, which is what we do in our calculator. And I'm not sure, since I missed the beginning, if you mentioned this, Alexandra, but with our tool, we're creating a simplified LCA. We're not going down to the granularity that you would get if you were using your own tools or using one of the more complex, full all phases LCA tools. What we're trying to do is get an acceptable enough score that's close enough to what you would get if you did a full LCA, but then is still adaptable enough to work across product categories. So we're simplifying the process a bit, and we're still working on the optimization part, because as we do testing with our clients, we're realizing there are some areas that we've made assumptions that we can use averages, but for example, weaving can use anything from 1 kilowatt hour to 28 kilowatt hours. So depending on the thread or the yarn size. And so that we're retroactively adding more steps in there to optimize the calculation model, till we get to a point where we feel that the results are close enough. We're trying to go for close enough, in our mind, is 90% of what you would do if you would do this manually. It's a bit ambitious, but because we're using averages, you're not going to get the exact same numbers as you would if you did your exact supply chain. So that's something to keep in mind. I mean, you do have to compromise a bit when you're using a tool like this that's going to work across categories.
Sean, I want to just emphasize that and say, in my mind, I think that's great, because you may be going 90% of the what you do in a full LCA, but it's not nearly 90% of the work. I mean, having done LCA work, you can work really, really hard for months for that last 10% and still come up with the same decisions that you would make from an 80% or a 90% solution. So I want to just really underscore that I really appreciate what you're doing.
Right, and thank you. And the other point to make is there is no real true 100%, because you could have 5 consultants doing the exact same product and come up with totally different numbers, depending on what methodology they use and what they decide to include in their LCA calculation. I think you probably mentioned some of that in your presentation. So it's really hard to define 100% accuracy when it comes to an LCA. And those, if you do it a year later, you'll probably get another score, because the energy mix will have changed in that country. So the energy, which is everything in when it comes to global warming potential, is most of the impact that you're going to get. That's constantly changing in real time as more renewable energy comes into the energy mix. So those, in theory, your impact score should go down year by year as energy mixes become more renewable.
Yep.
For the same product.
Good input. So I was thinking, as a next step, that we would walk you through how you actually conduct a calculation with the 2030 calculator.
That's great.
So just the basics here, you go into 2030calculator.com and then you sign up for an account. And you can start with sign up for a free account and just test it out. And when you're using the free account, you can still access the exact same type of data that we have for the subscribers. The difference is that you can't work with your full product library. In order to save calculations and work on them continuously, you have to become a subscriber. And you subscribe for 40 euros a month. So it's really not a high price compared to the other tools that are out there today.
Just to add something to that as well, our initial ambition was to provide this tool for free, but we're sourcing, we wanted to have the most robust data, underlying the calculations. So we've had to source and license data from a number of different data providers like Eco and Bent, and they're all charging us for this. So, we have to pay them, for that. That's why we had to end up charging a subscription fee, which wasn't our ambition from the start. But just a quick explanation around this. We're not in this to, necessarily to be profitable. We want the best data, and unfortunately that data is not always free.
Yeah, that's a very good point. And as you were mentioning, Sean, we have this kind of thorough process where we neutralize or normalize all of our data points that goes into the calculator. And we are very picky on really choosing the highest quality data that is out there. And that means that we've ended up with a lot of data from EcoInvent, as Sean was mentioning, which are really in the forefront on keeping their database accurate. So they're continuously updating all of their emission factors, but we're also using some open source data as well. And we have on our, if you go to support here in the right corner, you can read more about our methodology and the data sources that we source data from. But that's really the basics of the calculator, that we source this impact data per, for example, raw material. And then when you want to do a calculation, you start with inputting the overall product information about the product that you want to calculate. Then you break that product down into each material part. And then you can also add processing steps for those materials. And then lastly, you input information about your manufacturing facility. So just to give an example here, we are making a pair of jeans that are not Levi's. It's Alex pair of jeans. And let's say they weigh 500 grams. And then you choose which product category that this product belongs to. And here you can also see which ones we have available as of now. So we have apparel, accessories, books, crafts and watches and jewelry, furniture, hobby stuff and household appliances, shoes, etc. So these are the ones that we have. The ones that we will enable soon are foods and beverages, as well as cosmetics, beauty, and pharmaceuticals.
Sorry, and just to jump in really quick, Alexandra, I'm not sure if you mentioned that we're calculating cradle to gate, and for us, gate is the distribution center for the brand. Because if you do that extra mile, last mile to the retail store, you would get a different score for the same product depending on which shop it ended up in. So, we use the brand distribution center as the endpoint for our calculations. And then we're looking at developing a separate scoring system for usage and end of life, because that is such a, more of an educated guess on who your end customer is going to be. So, we want to keep that separate so that the consumer, if somebody decided to use our tool to start labeling their products, the consumer can make a choice and understand, okay, this is the impact up until I buy this, and then we can have a different system to allow consumers, to help them understand, what their options are in the use phase. But we wanted to separate those two so we keep brand responsibility or manufacturer responsibility separate from the end user responsibility.
Yep, good input. So after choosing your product category, you can choose if you want to add the product packaging for this or not, depending on if you have it, obviously. So if you don't have any specific product packaging, you don't have to add that one. And then the next step is to break these pair of jeans down into each material part. So for example, you usually have a denim part in your jeans. Then you go into which material category that denim comes from, so textiles, and you choose your subcategory. And here we have some options available. And as we go and as we work with more brands, we are continuously adding new materials depending on their need. And that's also something that differentiates us from other tools out there. Most of those tools are just like a big database that you have to go through and understand, okay, which are actually my materials that we are using. while we are trying to have a more market-driven approach where we're adding everything depending on what the customers actually need and what they're actually using. So here we have 3 different denim options. And in some of these subcategories, we also have different qualities. For example, if it's organic or if it's recycled or anything like that. And if, for example, you wanted to calculate a denim that is made out of recycled material, then we would add that for you. Then I fill out the weight of this material and where my supplier is located. So let's say China. And then I select the mode of transportation from my supplier to the manufacturer. And here we also have some initial selections or choices. But if there's something that is missing, we will also add that for the client. And here is where it starts to get a little bit more interesting. So if you know exactly how you're treating this pair of denim or this material, you can then add all of these processing steps that you have for that material. And you can do that for each individual part that you have. So here is really where the accuracy level comes into play to your calculation, depending on if you have all of the data needed to add all of this specifics, or if you don't know them. And then if you don't know them, we will use an average data point. So for example, if you would not even know the subcategory of your textile, we would use an average factor for that instead. So you could still get an indication, but it would of course be not that accurate compared to if you know exactly what type of denim it is, how it's processed, etc. So here I can choose, for example, if I'm bleaching these denims, I can choose which type of energy I'm using at that facility. If you choose the non-renewable energy selection, which is by far the most common one, you use the grid mix for that specific country where your facility is located. So that's the most common one, but in some cases, you have 100% renewable energy, and then you can choose that one. We are working on an update of this where you will also be able to input your specific mix of renewables and non-renewables. If you know, for example, that you are using 60% renewables and 40% grid mix, for example, you can choose that. Then you can also, if you know how much energy that is consumed, you can enter that yourself. We will also come up with an estimate based on what type of product it is and the process. If you're leaving the process location field blank, we will assume that this process is happening in the same location as you have your facility here. But if you have another facility, you can enter that as well. And then you just continue. So then you add the other parts of the jeans. The zipper, for example, you choose your material category. And if it's, for example, made out of copper, you can choose that. And then you enter the weight. And the important part with the weights are that you have to, all of the parts, the weight of the parts, the individual part have to add up to the total weight of the product. So that's one check that we do to ensure that you actually calculated all of your individual parts. Then you enter the supplier location for that and the transportation mode. And then, as I said, you just continue until you completed your product. And then lastly, you end up at this tab, Energy and Transportation, where you input information about your manufacturing facility. So let's say that these pair of jeans were manufactured in Milan in Italy, and that we're still not using renewables, even if we want to. and that the distribution center is located in, let's say, Barcelona. And we calculate the distance based on Google Maps, but we also have a factor to ensure that we're not always taking the shortest route, because we know that that's not how these transportations actually go. So we're ensuring that we're not calculating a smaller distance than you actually have. And then lastly, you get your result.
Alex, before we start talking about the results, I just wanted to throw in a couple of questions that we've gotten on the chat.
Yeah, great.
The first question is about the privacy of the data. So as a brand might enter in the data, who has access to it? Who can see that data? And is that different in the free versus the paid tool?
Great question. So in the free version, no data is saved. So there's no record of what you're doing. So you can try it out however you like, and no one will ever know. In the paid version, the calculations that you're saving are only saved to your account. So they're not visible to anyone else. It's your choice if you want to publish these or not. What we work with some brands with is that if they have a proprietary material, if, for example, if they source this very low carbon footprint, let's say plant-based leather, for example, we could add that specific material for them, and then they can choose if they want that one to be visible for everyone who uses the tool, which we really appreciate when they do, because then brands can be better at sourcing new materials. Or they can choose, if it's really something proprietary to their business, they can choose to only have that material on their specific login. But the end score or the carbon footprint in itself and the product information will never be shown if the brand does not choose to show it.
Thanks. But it is, I mean, that data is accessible by Doconomy, I assume. It's something that you have cloud access to.
Oh yeah, of course, we own the database, so we have that data, but in our user agreements, we are not allowed to use that if the brand does not say that it's okay.
Got it. That's clear. And then in a second question, in the input process, it looks like currently pretty manual. Is there a way to automate that by connecting to existing product systems to pre-feed the data in?
Great question. Yes, we are working on that. So it's not we launched this, and I forgot to say that in the beginning, we launched this, the version using now in mid-April. So we're in a quite early stage still, but we're getting a lot of requests, which is great. So that's one of the most common requests that we've gotten so far, that brands want to calculate thousands of products and not just one by one. So the first version of that is a more simplified API solution where they fill out a form with data and send that to us for thousands or hundreds of products. And then we upload that for you to your profile here. And then you get all of the results inside this login. So that's one version. And the second version that we will launch in a couple of weeks or a month from now is an API that is, of course, possible to integrate from example from PLM systems or ERP systems, or where you have this type of data accessible.
Great.
The challenge we have with that, with complete automation, is this data is scattered across any number of systems, that differ from client to client, and in some cases, some of it is still missing. Like, some of it they may need to contact the supplier to get. And so it's a bit of a challenge to be able to automate pulling all of the data, for every product. I mean, there's always going to be gaps. And, we have to come up with a solution that will work with any type of ERP or PLM system, and there are a number of different varieties.
Yeah.
So that's going to be it'll take a while before we can cover every type of system, and even then there will still be gaps that have to be filled in manually.
For sure, absolutely. And speaking of filling in gaps, we had one question about asking if there's a way to track or add secondhand materials such as unknown dead stock or upcycled material in the process.
Yeah, so that we can add those materials for you. Usually, since they're not existing, there is no impact factor for those materials in any commercial database. We have to calculate a new impact factor for that material ourselves. So that's something we can do, but it does come with a add-on cost.
Got it,
Yeah,
thanks.
I mean, basically our LCA consultants don't work for free. So we have, when we have to do the manual calculations, you know, we basically, it's, you know, paying for hours is what it comes down to.
Yeah. Great, thank you.
Good questions. Thank you so much. So here is then the result of this calculation, the pair of genes. And here we can see that the materials were by far the biggest contributor to this footprint of 5.33 kilos CO2. But since I did not add any packaging, that's why it says 0 here. And then we can see that energy was the second largest contributor. And then lastly, we have transportation. So you get
That
this
score
result break.
looks, that score looks really low. I think you might have missed a few things on the way in the,
Probably.
it
I
should
usually
be,
get
yeah, it
eight
should
or,
be quite,
8 or 9.
quite a bit
Yeah.
higher.
Yeah.
Yeah, I mean, we didn't
But
go through every part, but
no.
I mean, it, you know, cradle to gate should be about, you know, above 10 kilograms. So there's something we missed there in that.
Maybe
But,
400, 500 grams is way too little. That
Yeah.
you guys know that better than me about how your products are constructed.
I think it's
But
more the processing steps, because those really are the energy consumption. That's where most of the energy consumption is.
yeah. So after I have this result and can see the breakdown, I can choose to save this to my profile. So that's what I meant with the value added services that we put on top. If you are a paying subscriber, then you get the possibility to save this calculation, and then it will end up here under my products. And for example, if I had another pair of jeans here that I wanted to calculate, I can just go into my products and I can find the specific calculation and I can duplicate it. And then I can go into that copy of it and just modify the small changes I have there. So that is how the tool works.
Alex, there's one more question about some of these inputs. When you're talking about transportation, are you taking into account that transport is starting to become electrified?
Sean, you have to answer that.
At this point, we don't have any electric modes of transport in our database, but that's something we have to add pretty soon, because that is becoming an issue. And also, as we're looking to add foods into, you know, as another category that we're expanding into, we'll obviously have to have refrigerated transportation and other options that we currently don't have. So we're constantly trying to, you know, add more and more impact factors as we go. But you know, we're very much still, you know, developing this on a continuous basis.
Yeah, if I can just editorialize a moment, I think it would be great to have separate electrified transport options if brands can choose them. But in general, I mean, assuming that you're pulling the, you know, US EPA or DEFRA or other standard factors of carbon per ton mile, that's going to include some of the improvement in fuel economy with the electrification and with fuel economy savings, just in general, overall, on average for those regions.
Right. We just should, you know, we just have to differentiate it somehow. So, you know, people that know that they are using, you know, either all standard or, you know, partially electric, you know, they can input that so that we can get the right factors.
Yeah, that's great.
In the calculation.
Also, I was thinking if we're sticking in that energy and transport tab, It's great that you have the choice of choosing renewable energy. I think the reality for a lot of brands is going to be partial renewable energy and partial non-renewable energy. So it'd be great to put either a percentage or a number of kilowatts or but
yeah, I think Alexandra, you might have mentioned that, but we are looking at doing a type of a slider where you can adjust the mix. At the moment, we started with a really simplified version, and we're now adding more granularity to all of the the different input variables. But at the moment, if you pick non-renewable, it assumes it's 100% non-renewable, and anything else we're just defaulting to the energy mix for that country.
Oh, that's great.
The average energy mix for that country.
Yeah, I appreciate that.
Any more questions?
No, that's it so far, Alexandra.
Great. So we look forward to see you guys on the platform then. And if you want to, we could also offer all of you who are listening in on this a month trials of the paid version, so that you could really start to familiarize yourselves with the tool, and see if it's something that you want to continue with. So when we can maybe do a follow-up and send up the link to the movie, and then you can get that code as well for that.
And most importantly, provide feedback and input on how we can improve the tool, because that's really where we're, as we're developing it, the feedback we're getting from input we're getting from the customers who are using it is really what's driving our priorities on optimizing the tool. So that would be very helpful and useful for us.
Yeah, Sean, as we, I don't know if you got an introduction to 11 Radius. We're a membership organization, and so we have some members that have been looking at using LCA tools. And given that I have a bit of background in that, I've been working with a couple of them to think through how to do, in general, life cycle thinking and then some LCA work. And so we can kind of get a sense of how our members are using your calculator and sort of aggregate some of the challenges, the questions, the requests, and hopefully develop an ongoing dialogue with you about how it can be useful to our membership.
That would be great.
I'd like to jump into that question, Alexandra, actually. So within your customer base and customers that you're talking to, whether existing or future, who are you usually identifying in the company that should be tackling this and using the product? And are there ideal groupings of individuals? Who do you recommend should really be doing this? And is that what you're seeing as a reality?
Yeah, well, that's a great question, I think, because it all comes down to how much the company prioritizes this, of course. How much do they see this as a part of their business versus maybe a part of, more CSR work? So I would say, like, if we have the CSR work, then we have the value that it puts to the brand, and then we have if it's connected to the core business, and that's like the 3 levels that you have in terms of integration of sustainability into the company. And depending on where you are on that journey, it's different people that we're talking to and that are interested. Usually at this stage in our tool, we mostly see companies that are quite mature in sustainability. So they often have some kind of, even if it's a small company, they have some kind of sustainability or material expert that knows these data points and knows these types of, maybe not knows the calculation in itself, but understands how the factors correlate and have the information about the production chain. So it could be any of those people, but it could also be for example, in some cases, someone from marketing, so a CMO, if it's more related to the brand and how they communicate to their customers. In a few instances, it's been the CEO, but that's at really small companies, like newly founded companies where the CEO does a lot of things. So that's the types of people that we meet. But I would say, of course, ideally you want to work or this tool is made for people who know a little bit about their supply chain. Now, they don't have to know everything, but they have to have some kind of knowledge about what is a material process and how do they differ, and where do we, for example, if they start playing around with it, they could also find that, okay, if we switch from this process to this process, that will have this type of impact on our total emissions for this product. So that's where we really want to end up. And for that to happen, I think it has to be some kind of product specialist or someone who is into the manufacturing process.
Just to add to that, it's important to emphasize that we're trying to create a universal scoring system, again, that is accurate at an acceptable level of accuracy. We're never going to, the intention is never to replace existing tools that a company that is really, that has a team of LCA consultants doing, actual full LCAs, on every impact factor imaginable, will never get that level of detail that they require to do their own, for whatever reason they're doing their LCAs. But they see this then as a complement that allows them to then get a score on a methodology that another brand is using, and then we can start the process of comparing products, on labels. So, for if you really do, if you need that granularity, you'll still need to, do a full life cycle assessment. This is a simplified version that is going to get you close to what you would get at this point just for global warming potential or, carbon footprinting. And that's the ambition. So with that said, we want to make it as simple enough that even a CEO could use without having having to have an LCA consultant on the team. And that's, so we want to have that balance of usability, but still get the accuracy right, so it's not too far off from what you would get if you're using a more sophisticated tool.
I'm glad you brought up the product level comparisons and Alexandra, even the marketing department using this, because I think we're starting to see more and more comparisons to other products. And Asheen, you kind of presented it with the Levi's example in, a presentable, Levi's doing it in a presentable way to certain vegetables or time in a car. How is that information usually accessed? Like that comparison, not to another like type product, but to duration of a drive or distance, or how is that being done? Facilitated by your calculator? And this question is for both Asheen and Alexandra, I guess, and Sean, of course.
Yeah, I can start with how we look upon it at this time, at least. So we are well aware of the fact that when our users or the brands on the platform start calculating their product carbon footprints, what happens is that when they end up with this number, they don't know if this number is good or if it's bad, or like where on the scale they are, which leaves them quite confused. And sometimes they feel so confused that they don't want to risk anything, so they don't want to put this number out there because they don't know if they will seem bad or good by doing so. So what we're working on to try to encourage brands to understand where they are and in which, if they're really good or if they maybe need some improvements. We are now then developing like a product average index. So an index made out of product averages instead of specific calculations, which will then be a benchmark towards your specific calculations. So then you could see that, okay, I'm actually 10% higher than the average footprint. Okay, maybe I should go and do some adjustments before I put this out there, because otherwise I can't do that proudly. So that's one way that we're tackling this. Then the other part of it, I think, is that consumers at this stage of time might not be able to relate to carbon and kilocarbon, like what is even that? And I think that that's a really, really large issue, but I also think that making too many comparisons might also in some instances confuse the consumer, because we're often looking at how you introduce the calorie system within foods and beverages as an example of introducing a new term that no one knows about. But then if you repeat it and you do that in a very system-based approach, you can actually start teaching the consumers about this, even though I don't think anyone today can say exactly what a calorie is. But we know that, okay, we're supposed to eat these many, like if we look at a package of cereals, so we can see if it's way too much calories or if it's actually okay amount of calories. And that's where we want to end up
We've
with
developed an
the carbon
intuition.
footprints. Yeah, exactly.
And that leads to another question of mine, which dovetails on what Tara is asking, which is we're looking at results, 5.33 kilograms of carbon equivalent, and segmented into some of the life cycle stages of materials, packaging, energy, transport. How do you recommend that a brand would use these results? Do you recommend that they are accurate enough that they could put these on their customer-facing webpage? Or do you recommend them for internal consumption to see what to focus on, as sort of a hotspot assessment? I mean, in the quick LCA that you've done, I would glance at this and say, oh, our materials are a big part of our impact. Let's focus on those. So it's a useful hotspot test. But do you recommend that these can be customer facing, or how do you recommend using them?
That's a great question. And ultimately, that's where we want to end up, of course. But it all really comes back to how much accurate data that you input around your product. So did you only use the averages? Then maybe this should not be put out there because it will be pretty far from the truth. It will just be an indication which you can use to learn more and know where to direct your resources to lower your footprint. But I think, I mean, it's up to every individual brand to judge how comfortable they are in putting their footprint out there. But what we will do as an add-on feature on this platform, which will be introduced later this fall, is the possibility to when you've calculated your footprint and you're satisfied with the results and you feel like you've done your homework with the data inputs, then you can certify this calculation, meaning that you basically go into an agreement with us saying that all of this data that I've inputted is correct. And we say that, okay, this is actually calculated by the 2030 calculator with this methodology, covering cradle to gate, etc. And that then will result in a certificate and then also a carbon label that you can put on your product or on your website or wherever you would like to communicate it. And I think that's a good step, because then it really kind of puts the brand in the position where they have to actually take a stand saying, okay, am I happy with this input data? Because this data will then be visible for my customers. They will see that this was what I inputted around the product. And if that's not correct, or if that's not detailed enough, that will probably hurt the brand. So I think, and I hope that will be kind of a self-regulatory mechanism in the platform where the brands will probably not start publishing until they feel that, okay, we have enough data to support this footprint.
And does that, Alexander, do you imagine that will come with some level of third-party verification? Are you that third party, or do you have LCA consultants on hand who will do that sort of validation?
We consider that since, of course, that's like the initial thought that you get with the certification, that it is a third party that looked into it. But then our goal is not to become this, slow-moving organization. We want to build a platform that can scale quickly, and therefore we looked at other ways of certifying products and found that, for example, the CE marking that you use in Europe is actually self-declared, which means that there is a set of rules that you have to follow to put the CE logo on your product. But as long as you say and you actually commit to follow all of these rules, then you can put that on there. And then sometimes they do some random testing to verify that your product is actually following all of that. So that's more the system that we are trying to create, where the brands have to commit to their input, to their data, and we commit to the methodology, But then the end result is self-declared. So it's no third party that is going in and validating it. And we think that if we go down that road, we will build too much of a threshold for smaller companies, because that will cost so much more for them.
That seems reasonable. It seems like as long as you have a fairly well documented set of principles of this is what good data looks like, and brands can sort of self-assess against that set of principles. I think that seems like a reasonable in between, with not waiting for third-party validation, but also not just having someone take a half an hour, throw some results in and say, look, this is my carbon footprint. So that's
exactly. And when we also have the product category averages in place, we will also know, like, if this is, 1,000% from the average, is probably something that's off. So that we can also, of course, then develop into a little bit more alarm system that we can use to ensure that there's nothing really fishy going on.
That's great. Tara asked a little bit about who in the individual brands are accessing this tool and using it. Are you able to talk about some of the brands that are using it, and how many users you have on the platform?
Sure. So we have around 1,800 users on the platform as of today. So those users started using the platform since mid-April, so just for a couple of months. And we have some brands that have published their footprint. Not sure if you know about them, because some of them are more local to Sweden or to the Nordics. We have Triva, which is a watch company. But then we also have Emeco, which is a furniture company. They do chairs, but mostly sold to restaurants and other businesses. And then we're working on several pilots as well with other companies, which I unfortunately cannot disclose, but that are much more well-known brands that you all would recognize, and the majority of them from the American market, actually. So it's really a mixture of different types of brands, all from the single product furniture company to, I'm working with another furniture company now that want to calculate their 4,000 furnitures with this calculator. So it's everything in between, really.
That's great. And we've talked about some quite well-respected brands that are very knowledgeable about LCA, that are sort of pushing you on the limits of the comprehensiveness of the tool, which is great. But I mean, 1,800 users, that really signals that there's a deep need for a tractable, simple to use calculator that's doesn't require an expertise in LCA or a fleet of consultants to be able to do. So I think there's really excited about what you're building.
Yeah, we are too.
So a question that arose for Sean, as some of our friends here might beta test or live test the tool, if they come up with feature requests, how should they get these to you? Is it by email? Is there a Google Doc? Is there a function within the tool to submit them? What's the best thing for you?
We have email addresses in the tool, but since you're on this call right now, and you could just email Alexander or myself directly, because that'll be a bit quicker. It takes us, we have a backlog of emails that are in the system that may take a bit longer. So you can also just email us directly if you have an idea or a question, and we just don't want to put our addresses on the site, otherwise we'd get nothing else done. But yeah, feel free to email us directly.
Wonderful. Alexander, if you could just share both those emails with me, I'll make sure to get them to the folks on this.
Definitely.
Excellent. Any final questions or comments from any of the folks on the call?
I would just like to say thank you to all three of you for so much learning today, and for this great tool that you built, Sean and Alexander. We're really excited that it exists now on the market, and looking forward to, I think, playing with it and testing it out. So thank you for your time and for being here. And if there are no more questions, Asheen, are you good?
Yeah, I'm good. I just wanted to maybe make some concluding remarks, which is life cycle assessment. My first advice is what Yogi Berra said: when you come to a fork in the road, take it. LCA is complex and it can be daunting to get started. The hardest part is to get started. And in fact, once you start, one of the things that you will reveal is that you have a lot more data gaps than you thought. And when you start looking at where does my leather come from, and questions like that, I'll end with one example. An LCA that we did included a bit of stainless steel. And when we asked our client, this was back in my LCA consulting days, when we asked the client, okay, what's the grade of stainless, so that we can calculate the impacts of some of the trace metals in there, which really affect the impact to the footprint. They said, what do you mean grade of stainless? We just, we buy it from our Chinese supplier and they send it to us and we put it in the product. And so a couple weeks later, they came back and said, we're really glad that you asked us to ask our supplier what the grade of stainless was, because it turns out that the grade of stainless changes month to month, depending on the spot commodity prices of the impurities that go into making the different grades of stainless. And so we went back and tested this particular component over the last couple of years and found that its strength varies considerably and breaks a lot easier when the certain commodities are cheaper. And so it's the type of thing that doesn't even really relate to impact. It relates to the quality and transparency of your supply chain. And so LCA is a great way to start revealing that and understanding how it affects your business and your product, as well as how it affects the social and environmental fabric on which, no pun intended, your product rests. So I'll leave you with that, and I'll leave you with, hopefully getting started. We're certainly here to help with advice, and you will have all of our email addresses to ask all of your questions. And so let's all move this space forward.
We'll be sharing the link to the recorded session if you want to share this with anyone on your team who wasn't able to make it live today, as well as I think Ashin's slides and links to any the videos that were present. So thank you everyone for being here. It was really great to have you, and we look forward to seeing you at the next learning session.
Thank you so
Thanks,
much.
everyone.
Thank you.